Notes 4.3 are on exploring graphs of the primary trigonometric functions. So the first thing that we're going to do is complete the table using a calculator in the unit circle shown to approximate each value to 2 decimal places. So the first thing, in order for me to be able to do this, is I need to look back and find my unit circle, and I need to use that as a reference. That unit circle is going to be critical in everything that we do for the rest of this unit, okay? So when I have my unit circle in front of me, I can use that to help me find sine of theta as well as cosine of theta. Now, don't forget that sine of theta is going to be equal to all of our y values in our unit circle, because remember, when we do our triangle, sine is going to be the opposite over the hypotenuse, but the hypotenuse is 1 because the radius of a unit circle is 1. So when I do y divided by 1, I get y. And don't forget also that the cosine of theta is going to be x because we do adjacent over hypotenuse, okay? And so in order to do this, I need to look back at my unit circle. So I'm going to have it in front of me, and I'm going to use it to help me out. So let's do our sine part of our table first. So I'm going to do all of this in green. And it says to approximate each value to 2 decimal places. So we're also going to need a calculator. So when we've got a 0-degree angle right here, according to my coordinates, the y value is going to be 0. So the sine of 0 is 0, okay? And this is review from last year, except now we're using radians instead. When we've got pi over 6, we've got that our sine value is 1/2. So we're going to say that this is 1/2 or 0.5. When we've got pi over 4, we know our sine value is the square root of 2 over 2. So I'm going to figure out what that value is going to be. So the square root of 2 divided by 2 approximately is going to be 0.707107, so on and so forth. But I believe the directions say to do to 2 decimal places. So we're going to say that it's equal to the square root of 2 over 2, which is approximately 0.71. Okay? Now the next one right here, the sine of pi over 3, so I'm going to go to pi over 3, and it's the square root of 3 over 2. So I'm going to say it's root 3 over 2, which is approximately, and then we'll go ahead and calculate that value. So take the square root of 3, and then I'm going to divide that by 2. And I end up getting 0.87 when I round it to the nearest second decimal place. So we'll say right here that it's approximately 0.87, okay? Now pi over 2, the sine value is just 1, okay? When I go to 2 pi over 3, the sine value is the square root of 3 over 2. So we can say it's root 3 over 2, which we figured out is 0.87, okay? When I go to 3 pi over 4, we've got root 2 over 2, which is approximately 0.71. 5 pi over 6 is 1/2. We know that 1/2 as a decimal is 0.5. And then when we get to pi, we get -1. So we know, we get 0. So 0 is going to be the value for the sine of pi. Okay, let's keep going. 7 pi over 6 right here. The y value is -1/2. So we're going to say that it's equal to -0.5. Okay? The next one is 5 pi over 4, and the y value is negative root 2 over 2. So that would be approximately -0.71. Okay? 4 pi over 3 is negative root 3 over 2. So we can figure out that that's approximately -0.87. Okay? 3 pi over 2 right here, we know the y value is -1. And then we're just going to keep going. I'm going to move this up so we can kind of see our values a little bit better right here. Over here, for 5 pi over 3, when I go to 5 pi over 3, we get negative root 3 over 2, which we know is approximately -0.87. At 7 pi over 4, we get negative root 2 over 2, which is approximately -0.71. And then at 11 pi over 6, we end up getting -1/2, which is -0.5. And then at 2 pi, we end up getting 0. okay? I want you to do the same thing for cosine. I'll get you guys started on cosine, and we will do cosine in a different color. So sorry about this right now. So cosine is going to be all of our x values. So when I look right here, all I'm going to do is look at what my x values are. So I'm going to get you guys started, and then you guys can check or finish it up on your own and check with my work. So right here we get 1 is our cosine, is our x value when our theta is 0. So this will be 1. When I go to pi over 6, my coordinate, my x value of my coordinate is root 3 over 2, which we figured out is approximately 0.87. When we get to pi over 4, we get root 2 over 2, which is approximately 0.71. And these values should be the same, which means our graphs are going to intersect at pi over 4. When I get to pi over 3, my x value is 1/2, so I get 0.5. And then when I get to pi over 2, my x value is 0. And then I'm going to keep going from there. So fill in the rest and then come back to me to see how you end up doing. So these are the values that you should end up getting. So please press pause and just double check to make sure that all of these values are correct. All right, so question number 2 says to plot the ordered pairs 0 or theta sine theta and sketch the graph of the function y equals sine theta. So let's go ahead and do that first, and then we'll do the next piece afterwards. So if you notice, your graph is split up right here into pi over 2 pi, 3 pi over 2, and 2 pi, which means that this right here is going to be pi over 6. Okay, this is going to be pi over 3. This is going to be right here is going to be 2 pi over 3, because we're just going up by pi over 6's every time, and these are the simplified values that we end up getting. This right here is going to be 7 pi over 6. We've got 4 pi over 3 here. We've got 9 pi over 6 over here, which is 3 pi over 2. We get 10 pi over 3 or 10 pi over 6, which is 5 pi over 3, and then 11 pi over 6. Okay? Now, one thing I want you guys to notice is the fact that you don't have a pi over 4 or a 3 pi over 4 or a 5 pi over 4 or a 7 pi over 4 in your graph here. That's because we're going up by thirds, or excuse me, by sixths right here instead of quarters. But if we have pi over 2 right here, that means that pi over 4 will occur halfway in between, okay? If pi is right here and pi over 2 is right here, then 3 pi over 4 will occur halfway in between. Here's pi and here's 3 pi over 2, so 5 pi over 4 will occur halfway in between. And then between 3 pi over 2 and 2 pi, the 7 pi over 4 will occur halfway between, okay? Now, since my x and y values are only going, my y values are only going between -1 and 1, I'm going to go ahead and label my 1 up here, and I'm going to label my -1 down here, so that way I get a full view of what's happening here. So when the theta is 0, I get 0 for my sine value. So sine of 0 is 0. Sine of pi over 6 is 0.5, so I'm going to put a dot there. Sine of pi over 3, I'm going to skip this for right now. Sine of pi over 3 is about 0.87, so I'm going to go to about 0.87, so it'll look somewhere around here. And then sine of pi over 2 is going to be 1, okay? Sine of 2 pi over 3 is about 0.87 again, so it's going to be the same value over here. Sine of, I'm going to skip 3 pi over 4 for right now, and I'm going to go to 5 pi over 6, and that value is going to be 1/2. And then the sine of pi is 0, okay? 7 pi over 6 is -1/2. I'm going to skip 5 pi over 4 for right now. 4 pi over 3 is -0.87, okay? 3 pi over 2 is -1. 5 pi over 3 is about -0.87. I'm going to skip 7 pi over 4 for right now. I'm going to go to 11 pi over 6, and I know that that's -1/2. And then 2 pi is going to be 0. Okay? Now I'll go ahead and do my quarter pies right here. So pi over 4 right here is going to be 0.71, so it's going to be a little bit shy of my 3/4 mark, which makes sense in my graph right here. For the next one, the 3 pi over 4 is going to be also same thing, 0.71, so I'm going to put it right here. It's definitely appearing to fall within my graph, okay? The next one is 5 pi over 4, and same thing, it's about negative 0.71, so it's going to be somewhere around here. And then my last one for 7 pi over 4 is also negative 0.71, so it's going to be somewhere around here. Okay, so then when we connect all of our dots together, all of our coordinates together, we end up getting our sine curve, which is a complete sine curve right here, but it's going to keep going in both directions. Those of you guys who like to put a point at 0, and then a point at pi over 2, and then a point at pi, and then a point at 3 pi over 2, and then a point at 2 pi, and just tell me that your graph looks like that, or even that your graph looks like that, it's not enough. You need to have a good full idea of what's happening here. Okay, so now that we've done the sine curve, we're going to call this y equals sine of theta. I would like for you to please attempt the cosine curve and then compare your answer with me. So pause the video, do the cosine curve, and then come back to me to see how you did. Okay? Okay, so now that we've done that, we can fill in our chart below with all of this information right here. So sine of theta, I want to figure out its domain, its range, its amplitude, its equation of its axis, and its period. So let's go ahead and figure out our domain first. Well, x can be any value because this curve will continue going in both directions from negative infinity to positive infinity. So the domain of the parent sine function is x is an element of the reals. However, the range, it will only go from -1 to +1 right here. So our range is going to be y is an element of the reals, but y is going to be between 1 and +1. It can't be anything less than -1, and it can't be anything more than +1. Okay? The amplitude we'll talk about afterwards, but first I want to talk about the equation of the axis. So the equation of the axis right here is going to be the line that is horizontally, that's going to break my graph up so I have my horizontal line of symmetry. So right here, my line would be right here. Okay, so this is the equation of my axis right here, and the equation of my axis is just simply y equals 0 because it's symmetrical above and below my axis right here. So this is y equals 0. Okay, so now that I've found out that that's y equals 0, I want to find my amplitude. Well, my amplitude will tell me how high up it's going from my axis. So what the maximum is how much higher than my axis, and the minimum is how much lower than my axis. Well, the maximum is 1 higher than my axis, the minimum is 1 lower than my axis, so my amplitude here is going to be 1. Okay, and then the period right here is how long it takes to complete a full cycle. So how long is it going to take to complete a full cycle? It's going to take 2 pi to complete a full cycle because that's where we ended right here. We ended at 2 pi. Just like we did before in our 3U class, 360 is a full cycle right here. So we know that 2 pi is 360 degrees, okay? I want you to try the cosine one and then come back to me to see how you did. Okay, so if you notice, we will end up getting the exact same answers for sine and for cosine, which, by the way, sine and cosine are essentially the exact same function, except for the fact that the cosine is just the sine function shifted left or shifted right, depending on how you want to look at it, okay? All right, so now we need to look at the tangent function. So the tangent function, don't forget the tangent is going to be the y over the x. So now, since I know tangent of theta is y over x, I'm going to use my, my unit circle to help me figure out how to do tangent of theta. So right here, when theta is 0 degrees, I'm going to take my y, which is 0, and divide it by my x, which is 1, so I get 0 over 1, which is equal to 0. Okay? For my next one right here, I end up getting for pi over 6, I end up getting negative 1 or 1/2 over root 3 over 2. So I'm going to go ahead and do my work on the side so you can kind of see what's happening. So it's 1/2 over root 3 over 2. Okay, so that's essentially saying 1/2 times 2 over root 3. My 2's cancel out, so I end up getting 1 over root 3. But my problem right here is I'm not allowed to get a radical in my denominator. So I have to rationalize it by multiplying by root 3 over 3. So we get root 3 over 3 as my answer right here. So I end up getting that this right here is root 3 over 3, but I want to figure out approximately how much that's going to be. So I'm going to go into my calculator and I'm going to type in the square root of 3. And then I'm going to divide it by 3, and I'm going to get an approximate answer rounded to the nearest hundredth, which is 0.58. So I know that this value right here is going to be 0.58. Okay? When I have pi over 4, I can take root 2 over 2, and I'm going to divide it by root 2 over 2. Well, root 2 over 2 divided by itself will just give me 1, so I can just say that the tangent of pi over 4 is equal to 1. Okay? The next one that we have is at pi over 3. So I'm going to take root 3 over 2, my y value, and I'm going to divide it by my x value, which is 1/2. Well, essentially, that just means root 3 over 2 times 2 over 1. My 2's cancel, so I get root 3. So I know my answer here is going to be root 3, which is approximately equal to, so we're going to go ahead and evaluate what we get here. So we get the square root of 3, and I'm going to approximate my answer, which is about 1.73. So I can fill in right here that I get about 1.73. I do pi over 2, I want to take my y value, which is 1, divide it by my x value, which is 0, so I get 1 over 0, which is impossible, it's undefined. So I'm going to get an undefined value right here, okay? So then the next one that we have is 2 pi over 3. So to get 2 pi over 3, I'm going to take root 3 over 2, and I'm going to divide it by negative 1/2. So it actually ends up looking like this piece right here, except I've got a negative. It's a positive divided by a negative. So I end up getting negative root 3 over here. So if I get negative root 3, we know that root 3 is approximately equal to 1.73. So this is negative 1.73. So next we have 3 pi over 4. So if I look at 3 pi over 4, I'm going to take the square root of 2 over 2, divide it by the negative square root 2 over 2. So they're going to cancel each other out, so I end up getting just negative 1. Okay? And then for 5 pi over 6, it's going to look just like what we have here. I'm going to take 1/2, and I'm going to divide it by root 3 over 2, but this time we have a negative. So it's the same idea. We get root 3 over 3, but our answer here is going to be a negative root 3 over 3, which is approximately negative 0.58. Okay? Now that I've done that one, I have one more in this line, and then I'm good to go for this line of work right here. Lastly, I have pi. To figure out pi's answer, all I have to do is take my my y value, which is 0, and I'm going to divide it by my x value, which is 1. So it's 0 over 1, which is 0. Okay? Please use your unit circle as well as your calculator to help you fill in the rest of this chart, and be really honest with yourselves and make sure you give yourselves a chance to try it on your own before you check your answers with me. So pause it, see how you do, and then come back to me to see how your answer is. Okay? These are the values that you should end up getting. If you got something wrong, make sure you circle it and ask me in class so we can make sure you're 100% okay with this information. So question number 5 says, what do you notice about the value of the tangent ratio when cosine of theta is equal to 0? So if I have cosine of theta equals 0, remember, tangent of theta is y over x. So if cosine of theta is equal to 0, I'm going to get y over 0, which means that I'm going to get an undefined value. So it's impossible. Okay? So then question number 6 says, what do you notice about its value when sine of theta equals 0? Well, it will be 0 over some number, so I end up getting 0 when the sine of theta is 0. So if sine of theta is 0, then tangent of theta is 0. So what characteristics does this imply for the graph of y equals tan of theta? It implies the fact that we probably maybe might have some asymptotes when cosine of theta is equal to 0. Okay, maybe. We'll see if this really ends up happening or not. So let's go ahead and get our graph set up to go, and then we will move on from there. So remember right here, this is pi over 6, pi over 3, so on and so forth. And then our pi over 4s are going to be in the middle, smack in the middle. Okay? So, sorry, you're going to have to flip back and forth. But if you notice on your chart, we've got our highest right now, our highest y value is 1.73 and our lowest is negative 1.73. So I'm going to look at it from 1, I'm going to show 1 and 2, and then negative 1 to negative 2. So I'm going to look at it from negative 2 to positive 2, okay? And I know that the tangent of theta, when theta is 0, is going to be 0. Okay, I know that when it's pi over 6, I get 0.58. So I'm going to go a little bit above 0.5, okay? I know that when it's pi over 4, I end up getting 1. I know that when it's pi over 3, I end up getting 1.73. Okay, and then I know that when it's pi over 2, I'm going to have an undefined answer. So it looks like I might have an asymptote here. We'll see if we end up getting an asymptote or not. So then when it's 2 pi over 3 right here, I know that it's going to be negative 1.73. When it's 3 pi over 4, I get negative 1. When it is 5 pi over 6, I get negative 0.58. And then when it's pi, we get 0. Okay? And then we're going to just keep repeating the process. So at 7 pi over 6, we ended up getting 0.58. At 5 pi over 4, we got 1. At 4 pi over 3, we got 1.73. And then at 3 pi over 2, we have undefined. And it definitely looks like we're going to have an asymptote because this is going to keep increasing, and then if this starts down at the bottom, then there definitely is an asymptote here, which means that we have an asymptote right here as well. Okay, so then when we got to, we left off with 3 pi over 2. At 5 pi over 3, it's negative 1.73. At 7 pi over 4, it's negative 1. At 11 pi over 6, it's negative 0.58. And at 2 pi, it's 0. So this means that our graph is going to end up looking like this, okay? So this is what our graph will look like. So we've got a bunch of asymptotes, and every asymptote is going to occur at pi over 2, at 3 pi over 2, 5 pi over 2, so on and so forth. So every other half pi, we're going to have an asymptote there. So what's my domain? Well, my domain is going to be all real values except for pi over 2, 3 pi over 2, 5 pi over 2, so on and so forth. So we'll say x is an element of the reals, except x cannot equal. So let's see if we can get a pattern. It's not pi over 2. It's not 3 pi over 2. It's not 5 pi over 2, 7 pi over 2, so on and so forth. So essentially what you're doing is you're starting at pi over 2 and you're adding a pi on multiple times. So we're going to say x can't be equal to pi over 2 plus n pi, where n is an element of the reals. Okay? Or sorry, of the integers. For my range, I can see that my graph is going to go from negative infinity to positive infinity. So I can say that my range is y is an element of the reals. Okay. Now for my amplitude, it doesn't really have anything really happening where I'm going back and forth between something. So for this right here, the tangent wave can't really have an amplitude. The equation of the axis is going to be where it's symmetrical in the middle. So right here, the equation of this axis is going to be y equals 0. And then my period, how long does it take me to go through a full cycle? This time, we actually have half of a cycle here, half of a cycle here, and then one full cycle. So we got 2 full cycles within 2 pi, which means that we can get 1 full cycle just within pi. So this time my period is just pi. Okay, and that's what we need to know for graphs of trigonometric functions. All right, see you later.